My name's Kyle Taylor. I work for E1 Marine. I'm the engineering manager there.
Okay, excellent. In your presentation earlier today, you talked about a model that you used. Could you elaborate more on that model?
Yeah, we originally constructed the model to compare the emissions for the hydrogen one, which is the methanol to hydrogen electric pushboat that we're making with our partners, Maritime Partners. So we originally made the model to look at the emissions of that versus its contemporary diesel engines. Once we decided how useful that model was, we started adding the flexibility to make it generic to look at other load profiles and engine styles to make it a more useful model.
Okay, and what goes into that technology on board Hydrogen One that you used in that model?
Yeah, we have our hydrogen generators, which are methanol to hydrogen generators, so that they have built-in, fuel reforming efficiencies and power of plant. We took fuel cell data, which, the fuel cells have parasitics, and then there's also line losses to get all the way through DC-DC converter to get down to power at the prop. So we basically tried to sequentially go through Hydrogen 1 to account for those various steps to understand what the full power load will be.
And what were the results that came from this comparative model?
The model shows that, firstly, regulated emissions of nitrous oxide, NOx, hydrocarbons, particulate matter, carbon monoxide, there can be a significant reduction in those because of how our technology works. It doesn't provide really high temperatures, so it's well below that NOx threshold. So that's a big advantage right there. The model takes into account, diesel efficiencies versus the methanol reforming efficiencies, which are on opposite ends of the spectrum. Diesel is not real efficient on the lower end, below 50%, and methanol conversion has, and fuel cells does better down there at the lower end. So we're able to show that you can produce less greenhouse gas, CO2 equivalent emissions with a methanol solution. Potentially, it all depends on fuel cell efficiency, how efficient the diesel engine is, if it's brand new, if it's old. We've tried to account for that. So it's a whole spectrum, but it shows in general there is a precedence for better emissions for a methanol-based solution.
I think you showed that a blend between grey and green methanol would be ultimately the beneficial in this model. Could you elaborate more?
Yeah, gray methanol is derived from natural gas, so that's pretty standard. And green methanol is a whole spectrum. It comes from all sorts of different sources. So there's different carbon intensities that you use for modeling that. So we used a Department of Energy value for green methanol. So we were able to calculate how much green methanol you have to blend with gray to hit the targets.
Could you provide us an update on the state of the Hydrogen One project as it is right now?
Hydrogen One project is still moving along. There's, this is the first time the Coast Guard's had to deal with something like this. So they're going through very meticulously. So they're still working on various aspects of the Hydrogen One.
Okay. And when is the anticipation that this will be built and operating in water?
It's a great question. I don't have the latest answer on that. I suspect it's probably going to be late 2024 or early 2025.